So first of all, what you want to do is, just like with derivatives, if you see radicals, you want to change them into fractional exponents. If you see these single monomials in the denominator, you want to use your properties of negative exponents and bring them up. So for example, I can separate this into 4 different integrands. So I can rewrite this as the integral of x to the negative 1/2 dx minus your integral. Again, I can change this cube root of 8x into 8x to the 1/3 dx plus your integral of 3. Now again, I've got the 4th root of x in the denominator, so I can change this into x to the negative 1/4 dx plus 1/2 dx. So what I can do is, by my addition and subtraction rule of integrals, I can integrate term by term. So now your power rule, the one rule for your integral, just like you have a power rule for derivatives, you have a power rule for your integral. So again, what you're going to do is you're simply going to add 1 to your power. So when I add 1 to negative 1/2, what is negative 1/2 plus 1? 1/2. So I'm going to get x to the 1/2, but what you also have to do is you have to divide by that power. So that's your power rule for integration. You add 1, and then you're going to divide by what that power is. So x to the 1/2 divided by 1/2 is going to give you a 2x to the 1/2. And like I said, you can check your answers by seeing what is the derivative of 2x to the 1/2. Well, the derivative of 2x to the 1/2 is going to be x to the negative 1/2. So you know that you integrated it correctly. All right, so any questions where I got 2x to the 1/2? So your power rule for integration, you add 1 to the exponent, and then you're going to divide by that new power. So any questions on what the power rule for integration is going to look like? So now you also have for integration, if you have a constant, you can yank the constant out and then integrate the variable. So I know that 8 to the 1/3 is actually just 2, correct? So I can rewrite this as a minus 2, pull that 2 out of your integral, and just integrate that x to the 1/3 dx. So just like with derivatives, if you have a constant multiplied by a variable, you can pull that constant out and integrate the x. So using your power rule, this is going to be a minus 2x. I add 1 to this exponent, so 1/3 plus 1 is going to give me an x to the 4/3. But when I divide by 4/3, that's the same as multiplying by 3/4. So then I have 2x to the 1/2, so then when I multiply a negative 2 times 3/4, that's going to give me a minus 3 over 2 x to the 4/3. So that takes care of this, that takes care of this. So any questions so far? So now when I do plus 3x to the negative 1/4, again, I can pull that constant out and integrate x to the negative 1/4 dx. So plus 3 times, again, I need to add 1 to negative 1/4. What's 1 plus negative 1/4? 3/4. That's going to give me a 3x to the 3/4. But then I need to divide by 3/4, which means I'm going to multiply by the reciprocal of 4/3. So that's going to give me a plus 3 times 4/3 x to the 3/4. Which, what happens when I multiply 3 times 4/3? That's just going to leave me a what? 4x to the 3/4. Again, I'll clean up my answer in a few minutes. So that takes care of this. Last one, I have a constant of 1/2. So I have 1/2 times your integral of dx. Now how do I integrate dx? Well, I know the coefficient in here is a 1. So what function has a derivative of 1? X. So the integral of any constant is just going to be 1/2 times x plus your constant. Again, we know if I take the derivative of this whole entire expression, it should get me back to the integrand. We don't know if there was a constant or not, because I know derivative of constants are 0. That's why you've got to write that plus c. So my final answer is going to be 2x to the 1/2 minus 3 halves x to the 4 thirds, again, plus 4x to the 3 fourths, plus 1 half x plus c. So any questions on using your power rule when it comes to integration? Yes, Chris?
Why, the 8, when you pulled it out, you made it 2?
Because it was to the 1/3. So the cube root of 8 is 2. Okay. Any other questions? So now, like I mentioned in part B, we do not have a product rule for integration. So what you're going to have to do is you're going to have to FOIL and you're going to have to multiply out the 1 minus t squared and then distribute a t to the 1/2 before you can actually integrate term by term. So we have to rewrite this as a sum or difference. So I know that this is going to be equal to the antiderivative of t to the 1/2 times. I want to multiply out 1 minus t squared, so that's going to be a 1 minus 2t plus t squared dt. Like I mentioned, we do not have a product rule. So you've got to distribute, get rid of the product, so let me distribute the t to the 1/2. So I have t to the 1/2 times 1, which is t to the 1/2, minus 2t. Now when I multiply t to the 1/2 times t to the first, what do I do with those powers? I'm going to add them. So that's going to be a 2t to the 3/2, plus t squared times t to the 1/2 is going to give me a t to the what? 5/2 dt. And now I can integrate term by term. So any questions on how I've gotten rid of the parentheses or the product that was inside the integral? You guys go ahead now for me and integrate term by term. So guys, let's take a look at this one here and see how we did using our power rule. Yes, you do lose points if you forget to write your plus. I forgot what? See, you're right. I wrote the 5/2.
Lost points.
I would have lost the point. You're absolutely right. Like I said, you would have lost the point if you forgot to write your plus C. Again, including your quiz on Monday. Shh, guys, including that little basic integral quiz on Monday. Don't have me take off a minus 1, minus 1, minus 1, minus 1, minus 1 because you forgot to do that plus C.
If we mess up like on all of this, can you just take off minus 1 entirely? Like instead of multiple.
How are you ever going to learn your lesson?
I will learn my lesson because I got a minus 1. But that's not.
All right, so any questions on that one? Now, like I mentioned, ladies and gentlemen, just like in number B, we do not have a quotient rule for doing integrals. So what you want to do is you're going to split this large fraction up into two smaller fractions. So I can rewrite this as 2 over y dy minus the integral of 3y squared over y dy. So I kind of did 2 steps in one. I broke up my larger fraction, and then I split my integral up to integrate term by term. So any questions on how I rewrote this? Well, looking at the second one, 3y squared over y. What is this fraction going to reduce to? This is just going to reduce to what? 3y. And hopefully we know now, or getting comfortable integrating using your power rule. Now, I do have a constant that I can pull out of 2 over y. The constant is a 2. So I can rewrite this as 2 times your integral of 1 over y dy. When you have a variable to the first power, a single monomial down there on the bottom, you're not going to use your power rule. Rewrite this as y to the negative first, because then you're ended up with y to the 0, which is a 1. When you have, the rule is, when you're trying to integrate 1 over y, the rule is it's going to be 2 times the ln of the absolute value of y. Because remember, you can't take the natural log of a negative number. So the rule is when you're integrating a 1 over x or a 1 over y, and again, think about what is the derivative of natural log of y. The derivative of natural log of y is 1 over y. So any questions on where I got this 2 times natural log of y from? Minus. Again, I can yank this constant out and just integrate y dy. And using your constant rule, again, this is a y to the first, so I add 1 to my exponent, so that's going to give me a y squared all over 2. And then again, don't forget to add your c. Okay? So any questions on C? Remind me again, what's the derivative of e to the x? Yeah, so guess what the integral of e to the x is going to be? E to the x. Like I said, you're going to learn to love it. You didn't like e to the x when you learned him back in Algebra 2, but he's our favorite one in calculus. All right? So when you have to integrate 1 over 3x minus 2e to the x, again, I can rewrite this integral as 1 over 3x minus your integral of 2e to the x dx. What constant can I pull out of 1 over 3x? What's the constant here? 1/3. So I can rewrite this as 1/3 times your integral of 1 over x dx minus, I can pull out the 2 times your integral of e to the x dx. And remind me again, the antiderivative of 1 over x is going to be what? L of x. So I'm going to have 1/3 ln of x minus 2e to the x, and don't forget your c. Yeah, it should be absolute value of x, yeah. All right? So now let's take a look at cosine of t minus cosecant cotangent of t. So again, just like your trig, you got to remember all your antiderivative rules for all your trig ones as well. So first of all, I can split this up. I can rewrite this as the cosine of t dt minus the integral of cosecant t cotangent t dt. So now you got to think about the derivative. What function has a derivative of cosine? Sine. So I know the antiderivative of cosine is going to be a sine t minus cosecant t cotangent t. Yep. No, sine. Because remember, this is the derivative of cosine. Because again, check your answer. What's the derivative of sine? The derivative of sine is a cosine. If this had been a sine inside, the integral of sine, negative cosine. So now the question is, what function's derivative comes from cosecant t cotangent t? Cosecant. Plus your what? Plus c. Now, what's missing in front of this cosecant? Negative. Why do I need a negative there? Exactly, because remember, the derivative of cosecant is actually a negative cosecant cotangent, isn't it? So I'm going to need to put a negative cosecant right here. So what happens with this minus and negative? It becomes a positive. Okay? So any questions, guys, on how you integrate, again, your trig? And again, these are on your yellow flashcards, so you have them to practice. Just like you had to start with derivatives, there's just a whole bunch of rules to memorize. All right, let's take a look at, so now what we've been doing in all those other examples, we have not had enough information to solve for C. So that's why we had to leave it in terms of a plus C. So when we have what are called initial value problems means that it's same as asking for a specific function. What this means is we're going to find a particular solution. And what this means is we're going to, given this condition, we're going to solve for C. So instead of having that generic function with a plus C in it, what we're going to do is we're actually going to solve for C. So finding a particular solution is the same directions as if they ask you to solve the initial value problem. What you're simply doing is you're solving for C. So they're giving you the derivative of x plus 1 over the square root of x. And they're giving you this condition y of 1 equals 0. So really what they want you to do is they want you to find the function who has this derivative. And you want to assure that it's going to pass through the point 1, 0. Well, in order to find your function when you're given the derivative, you're going to have to integrate. So f of x is going to be equal to the antiderivative of x plus 1 over x to the 1/2 dx. Just like I mentioned a few minutes ago, we do not have a quotient rule for integration. So you have to take this larger fraction and you're going to split it up. So I have x divided by x to the 1/2 plus 1 over x to the 1/2 dx. Simplify your fractions if you can. Well, what happens when you have x divided by x to the 1/2? That's just going to give you an x to the 1/2. Plus, I'm going to pull this x out of the denominator and rewrite this as x to the negative 1/2. So now I can just integrate term by term. So when I integrate x to the 1/2 using my power rule, I'm going to add 1 to my exponents. That's going to give me an x to the 3/2. Divide by 3/2, which means I multiply by 2/3. So any questions where I got 2/3 x to the 3/2? Plus, I need to integrate x to the negative 1/2. So when I add 1 to this exponent, that's going to give me an x to the 1/2. When I divide by 1/2, I multiply by 2. And again, I can't forget to add my c. Yes, Izzy? Yeah, I just integrated term by term. I just didn't actually write the integration sign twice. Now remember, this is just a general solution. That's what that is right there. So, since they're giving me the condition, y of 1 is equal to 0, what I'm going to do is I'm going to replace my x with a 1 and set it equal to 0 to solve for c. So 0 is going to be equal to 2/3 times 1 to the 3/2 plus 2 times 1 raised to the 1/2 plus c. Because what I want to do is I want to solve for c. So any questions on how I plugged in the 1 or the 0? So 0, again, 1 raised to any power is just 1. I have 0 is equal to 2/3 plus 2 plus c. So 2/3 plus 2 is going to give me 8/3 plus c. So what's c equal to? C is equal to negative 8/3. So any questions how I solve for c? Now what you want to make sure you do is you want to plug your final answer is going to be when you plug negative 8/3 back in for c. So I'll just write my answer here. So f of x will be equal to 2/3 x to the 3/2 plus 2x to the 1/2 minus 8/3. So there's your answer for part A. Okay. What do you think for part B? What is the integral of sine going to be? Negative cosine. What's your integral of 1 going to be? X. You guys go ahead and try B for me on your own. So hopefully, guys, we came up with, this is our final answer. So again, like I mentioned, the integral of sine should be a negative cosine, and the integral of t should just be, integral of 1 should be t. And then you plug in 1/2 for y and pi over 3 for x. And remember, you can't subtract the 1 and the pi over 3 since they're not like terms. So any questions on solving an initial value problem? Questions on that? So here's another spin-off on a way a question could be phrased in terms of an initial value problem. Find an equation of a curve. So now we're talking about equation of a tangent line. We want to find an actual equation of some curve. Maybe a function, it may not be, that satisfies the given conditions. At each point, x, y, the curve, on the curve, the slope is. Well, what is slope? Slope is simply your what? Represents what function? The derivative. So this is your dy dx. So I know that dy dx has to be equal to x plus 1 to the second. So they're giving you the derivative. And we want to ensure that it's going to pass through the point negative 2, 8. So this is another spin-off in a way they could ask an initial value problem. Remember, slope is the derivative. So they're giving you the function that is the derivative. So then to find the equation of the curve, they want you to find f of x. So again, what you're going to have to do is you're going to have to integrate the derivative, which is just x plus 1 to the second. And like I just did a few minutes ago, you're going to have to solve for c. Well, what are you going to have to do first before you start integrating this? You're going to have to do what? You're going to have to FOIL multiply it out. So f of x is equal to x squared, the integral of x squared plus 2x plus 1 dx. You must always, guys, by the way, put the dx at the end of your integral. Because again, if you don't, you're assuming that you're only integrating x squared and then you're adding the 2x and the 1 to it. So that way you know where the integral ends. If you don't have that dx at the end, I'm assuming you're just integrating x squared and adding the 2x and the 1 to whatever you get after you integrate. So make sure you put that dx right there. You guys go ahead and finish the problem for me, integrate, and then use that initial condition to solve for c. So hopefully we all came up with what c values you guys get. 26 over 3, exactly. So you should end up with x to the third over 3 plus x squared plus x plus 26 over 3. So any questions on, so that's just a spin on the, it's another way they could ask an initial value problem. Again, giving you, wanting you to find the equation of a curve, giving you a slope the slope formula. All right? So now before we start the last two trig ones, it's important that you guys remember all those lovely Pythagorean identities. Is there a function we know that has a derivative of cotangent squared? No. So this is where you want to think of those trig identities and possibly doing trig identity substitutions. Anytime you see a trig function squared, this is where you always think of Pythagorean identities because those are trig functions squared. So cotangent squared, remember, is going to be equal to cosecant squared theta minus 1 by your Pythagorean identity. So by your Pythagorean identity, remember, cotangent squared theta is equal to cosecant squared theta minus 1. If I manipulate this last Pythagorean identity I wrote, and I solve for cotangent squared. Now, look at the integral that I wrote. Is there a function whose derivative is cosecant squared? Well, what's the derivative of cotangent? Oh my goodness, good thing we're having a quiz. Derivative of cotangent is negative cosecant squared theta, correct? So then what is the antiderivative of cosecant squared theta then going to be? It's going to be negative cotangent theta. Again, the antiderivative of negative 1 is just going to be a minus theta plus c. Remember, you can use different variables. You could use x or you can use theta. Again, like I said, if you were to take the derivative of cotangent, it's a negative cosecant squared. So the derivative of negative cotangent is just cosecant squared. All right, so any questions on 4a? Let's take a look at b. Again, we have no quotient rule for integrals. I cannot change this integral into a tangent squared because the numerator is not squared. So what I'm going to do is I'm going to rewrite this integral as a sine theta over cosine theta times 1 over cosine theta d theta. And see if I can rewrite it in terms of different trig functions. Well, sine over cosine is equivalent to what? Tangent. 1 over cosine is equivalent to what? Secant. Now, think about your derivative rules. Is there a function that has a derivative of tangent times secant? Secant theta plus c. So sometimes, ladies and gentlemen, when you're integrating trig, you're going to may have to manipulate using your different trig identities to get it into a form of a derivative that you could recognize. And again, once you get your integral rules memorized, hopefully it becomes a little bit easier. So any questions on your integration? All right. Yeah. I figure we keep on going. We are BC, you know. We never stop.
Wait, yeah, we need